Our next speaker is Prathamesh, and we've been learning over the last couple of days everything about JRuby and performance and scale. So we said it's important to find out the new age of debugging. Prathamesh, over to you.
One more AI talk for the day. I think there is one more that is coming later in the day. My name is Prathamesh. I will be talking about teaching AI to debug our Rails applications. A quick introduction about me. I have been a Rubyist for almost 12, 13 years of my career. Been involved in the Ruby community in the Pune as well as with RubyConf India as well. I've been also contributing to Rails, not recently, but about 3-4 years ago. Was also part of the top 30 Rails contributors. And you can find about me on internet as well. I have my Twitter handle here. So, this is our reality these days, right? Most of the AI tools write our code, and then we spend so much time in debugging that code. How many of us write code using AI tools? Almost 60-70% of the audience? Great. And do you spend more time in understanding and debugging that code? Awesome. So I'll be talking about how you can make that process slightly easier today. And let's see how we can go about it. So this is the typical debugging paradox that we have today. We have too many tools, we have too much of data, but we don't know what to do with that data. Like as a engineering org, we are already using 2, 3, 4, 5 multiple tools. There is a APM, there is a logging platform. We have our own servers who generate also a lot of telemetry data. But whenever there is an incident, we have only 2 questions. What has changed and how can I revert it? Because that can help me quickly understand what's going wrong, and then I can also fix that or somehow get it to a condition where the normal situation prevails. So we have too much of data, but all of that data does not actually help us whenever there is a problem. The too much data actually causes a problem, and the problem is with context. Because of this data, we don't know where to focus, which data is useful, and how it is correlated with each other. And that's the debugging paradox that we live in. Almost always, we have to learn 3 to 4 multiple query languages. Like if you're using, let's say, New Relic, Datadog, they have their own query languages. If you're using any logging platform, they have their own query languages, and so on. So you have to almost always hunt for the information rather than the information being available for you. So let's try to solve this problem with AI itself, because now that we are using AI to write our code, why not use AI to solve this debugging problem as well? So let's see that in action. I will jump into the demo part directly, and let's see what's happening with my applications. Hopefully the internet will work. This is the actual live demo that is happening. This is not a recorded video. Let's see. All right, so I'm using Claude, which is an AI tool. Some of you might have used it already. I have asked it how my applications are behaving in production. It is a conversational approach. I have not asked in a specific query language, or I have not used any syntax. I just ask a random question that how my applications are behaving. What it is doing behind the scenes is it is trying to get the information from somewhere, and we'll talk about how that information is coming later. But it's trying to get some information, like what services exist, what exceptions exist, what alerts exist. And based on that, it is generating an overall health summary. Most of my services are running smoothly. There are few high traffic services. There are few backend services. Oh, there are some areas of concern that I should look at. And it has figured out that, hey, the error rate for my front-end service is slightly elevated. Like there is about 9% error rate that my front-end service is seeing. There are few active alerts that are also detected. And it also summarizes like which services are running well. It is asking me if I should do a deep dive, so let's go ahead with that and also understand overall picture from a system analyzation perspective, how my system is behaving for last few hours. So now it is going and like looking at the specific service, trying to find what's happening with that service. Note that in any of these instructions that I have given to my AI tool, I have not mentioned any specific service name, anything that you should ask, like go and find out a specific area of concern, nothing like that. I was just using a conversational approach to find out the information about my stack. And it will keep doing that. It will find out some critical issues, it will find out some bottlenecks, it will start giving recommendations. It can also generate RCAs for you, also give you information about where you should focus. By the way, it can also generate a plan of action for you for your next 2-3 sprints as well. And with this, I'll just end this demo, but this will keep going on. Like it will provide me different types of information and so on. I can also like check this information with my APM tool, with my logging tool as well, of course, and correlate and make sure that this information is correct. But 99% of the time, this will be the right information that is actually happening in the production system. So coming back to our slides, why we should talk about this problem now, right? Why you should think about using AI tools for debugging, and why today? Because that is also an important point to consider. Today, almost most of our code is being written by AI, right? And as we saw, about 70% of the audience today here at RubyConf India as well use a lot of AI tools for writing the code. And if you want to sell something, if you just say that it is MCP powered, greater chances of like selling it, right? Because that's the new hot word or the buzzword that exists today. But this AI native SDLC also causes challenges. Like AI is almost in every phase of our software development lifecycle. You start writing code with AI, you start generating tests with AI. AI tools verify your code end to end, also help you with summarization, debugging, and all of that. And also LLM models are also catching up. Like you saw the demo that I had where I only had to ask questions. The AI model behind the scenes took care of converting it into different questions that need to be asked specifically for various services and figure out the rest. But also, like with all of this, there is also a challenge of data that we spoke about earlier, which will go in more detail, like how to make this process more effective. So coming back to how we have solved it, the demo that I used was using an MCP server. MCP is nothing but a model context protocol. It is released by Anthropic, which is the company behind a very popular AI tool called as Claude. Some of you might have already used it. This protocol was released last year, and we have seen a massive improvement in just last 10 to 11 months itself, where all other model providers have also adopted this protocol. So it is not just specific to a particular company. This is very similar to a HTTP protocol that all of us use. Language doesn't matter, server doesn't matter, or what kind of framework you use, that doesn't matter. Essentially, all model providers like OpenAI, DeepSeek, Claude, Llama, all of them support this protocol for conversing with AI. And how it does it is it provides context to the AI. That's the real problem that it solves for. Because as a human, understanding all the context, making correlations, at a time when you want to debug something is very hard because we have to also think about from where all the data is coming. There is a lot of tribal knowledge that is also involved whenever we are debugging incidents. That problem gets solved by providing this context to these AI tools. We'll quickly go over the MCP architecture. We have had a couple of talks about MCP already, and they have covered some of these points, but I'll just cover a basic idea about how the MCP server is designed. So at one point, you have AI tools like Claude, Cursor, and different types of AI editors and so on. On the other side, consider this as a laptop where you have some USB ports. You are plugging into different USB ports. One is giving information from Slack, that somebody is complaining about an application degrading. Some other email is coming from a customer that, hey, we are seeing elevated error rates, the page is not working, so that is another input. And then you have some scale up, scale down events that are also coming from calendar. So there are different kinds of sources which are feeding information for our AI tools. There is a MCP server that is sitting in between, which is collecting this information, providing it to the tools, AI tools like Claude, Cursor, and so on. And then the models are taking over, inferring that information, giving you more context and what is exactly happening. They are giving you information about that. Very interestingly, the MCP protocol also allows you to access data locally, which is also powerful in a way because you can literally make it usable for a lot of other use cases as well, where you can't really pull data from other third-party sources. Like you can just dump the data, get it in a file, and access it using those file formats as well. Now, if you think about the MCP server, this is very similar to like the old RPC functions that we used to write. They're called as tools in the MCP terminology. So there will be a tool to get my exceptions, get services, get summaries, and so on. We saw some of those in the demo. Obviously, there are some challenges with security as well. We had a talk from Vlad yesterday. So any security question, I'm not going to handle it. Please send all those questions to Vlad. He's the best person to handle those. But we'll cover how you can use this protocol to leverage and empower your debugging. So every day you will hear somebody announcing a new MCP server. And I thought we should also write one MCP server for the RubyConf India conference this year. So I've written a small MCP server which monitors your Rails applications, and it provides some insights about how the system is behaving. Anybody already written an MCP server here, just to get an idea? Great, okay, perfect. We have few folks who have already written a couple of MCP servers. So we are going to focus on debugging, which is nothing but the exercise of observing our systems. So in case of writing MCP server for an observability use case, we want to give runtime context to our AI tools. And what that runtime context means is what's happening in my production environment, right? Is there any exception? Is there any surge in traffic that is happening? How my logs are behaving, how my services are behaving, and then let the AI model take over and give you the answers. So in the context of observability, we are trying to provide the runtime context to our MCP server so that that MCP server can pass on that information to the AI model. Now, what this solves for is typically the data silos problem, right? Like log data is somewhere, metrics are somewhere, APM, only few people in the organization can access APM because it is costly. We don't have all the information in one single place. So the data silos problem is one core problem that we are addressing. You don't have to jump between multiple tools whenever there is an incident. You can ask one single tool, one single command. It will try to give you the information from where you can go and focus on specific areas. We don't have to worry about learning different types of languages. PromQL, NRQL, Datadog has its own query language and so on. There is a conversational approach that anybody can use to access this data and understand what's happening. And of course, we are leveraging all the advancements that are happening in LLM models as well. We are essentially leveraging those models to infer this data, access the runtime context, and then make sense of it and provide us the details. So we should now look at the code as well, because otherwise we won't understand how these servers can be written. So I've written a quick server in Node.js. But you can also write it in Go, you can also write it in Ruby as well. Yesterday we saw an example of writing the MCP server using fast MCP gem. So you can also write it in Ruby language as well. I have just written it in Go. That's almost always supported by different platforms. Gautam is not happy, but you can also convert it into Ruby as well. So we saw tools earlier, and here also I have different tools. So let's look at the first tool. Yeah, so from here the tools are starting. I have first tool which is querying the application traces. There is some input that I have given to it that you should always start with a service name, and the LLM model can infer what service name to use. But whenever you are calling the backend, you should use a service name as an input, which will be name of the service to query. So anywhere we are giving a description, we are actually helping our LLM model to make right decisions, right? So those who have used these AI tools, you have to give right prompt to give the answers. Here the MCP server configuration is providing some additional prompt information to our AI tools to make better decisions at runtime. And I'll also talk about a slightly advanced way of creating these tools as well, where you can refer to one tool from another tool in case of, if you want to make sure that there are some preconditions. Let's say you want to study the production data first load all the production services and then try to access the telemetry data. So we'll also talk about that example shortly. But essentially, you can create these tools, you can give input, you can tell them how much data you want. Additionally, the quality of your MCP server will largely depend on what data your sources can provide, which also means that in this case, for a demo, I'm using Jaeger, Prometheus, Loki on my local setup, which have the telemetry data, and from there I'm pulling it in my AI model. But you can also use other providers as well. Like if you are using an APM or a monitoring platform, they might also have an MCP server that you can leverage. Most importantly, you can also mix and match MCP servers as well. So you can try to use multiple MCP servers together, one for your logging platform, one for your APM, and so on. Now, there are multiple tools. The MCP server has a couple of interfaces to access the data. It can either access it via JSON RPC protocol. There is also HTTP protocol as well, via which it can access the data. And then consider it as like a wrapper that you have over the data. You can transform that data, massage it, clean it, and then it will be passed to the AI model for accessing that data. Now, just to show this in practice, when we were running this information, you can see that it is actually making certain calls. So get service environments is one of the tool that is being called. There are no arguments to it, but the response that it got from the backend system is production. Then it called get service summary, it got some response and so on. So whenever you configure an MCP server in your AI tools, you will be able to see like what kind of tools that are available to it. Different kinds of tools that your MCP server supports are available here. I have my Rails MCP server as well, which has certain tools like understanding the Sidekick jobs, the Rails cache performance, and so on. So now we'll also look at it from a Rails application perspective as well. I have few Rails apps running in my local, and I have enabled the specific MCP server that I have created for today's demo. And let's see now if it gives me some more interesting insights about my Rails application. So the MCP server is running on my local right now. You can also host it and provide a hosted MCP server as well. The way it is running and configured is via configuration file. So it is running via node. I have given it a path from where that server is running. This is the same server.js file that we were just seeing, where the tools were defined. And now it will call some of those tools. It will detect some live issues, and then it will try to provide more information. Looks like there are some mixed signals, some inconsistencies are there. There is not much significant traffic. There are a bunch of services that it has found in my setup, and there are some possible scenarios that it is trying to infer. Now, while I'm showing this example using Claude, you can very well integrate it with your coding agents as well. Like the same way that I showed an example of integrating it with Claude, you can also integrate it with Cursor, VS Code, because all the model providers and tools support MCP protocol. You can very well leverage it with your coding daily SDLC technique as well, where you can basically get the runtime context of what's happening in production while doing the code, and let the system fix the code for you as well. So now, when I ask it to do some advanced deep dive analysis, it has actually found few interesting use cases related to Sidekick, Active Record, and so on. These are some of the tools that I have added in the MCP server for making it more of a Rails debugging experience seamless. And then it has found few use cases around N+1 queries, common Rails bottleneck that we typically run into. It has found few cases related to Sidekick processing, jobs which are running slow, how is the caching, and so on, related to views and so on. So typically, depending on the use case, you can add these specific tools, which can be very well specific to the problem statement that you are trying to solve. And for a Rails debugging experience, I have covered most of the common Rails components that one needs to look at from a performance optimization perspective. So yeah, so this is a quick demo. Coming back to the coding part, also wanted to show a slightly advanced example of giving tool descriptions. So this is another MCP server that I have written. This is written in Go, but again the semantics are same. It internally implements the same MCP SDK and MCP protocol. What I wanted to focus here on is the description. So what this tool does is it gets the service dependency graph for my services, and look at how detailed the description can be, because this is how your MCP server will provide the information to the AI tool. And the AI tool can leverage this description to do the correlation, do some pre-fetching of data that is needed for performing better. For example, in this case, I have mentioned that you should get an environment to filter by, but use the get service environments tool to do that. So you can refer one tool from another tool to doing this kind of analysis. You can pass on more information about how to structure the data and how to get as much context as possible for the AI model to give you better results. I think there is also an example of giving some queries. So here there is a PromQL query that is given. So you can also provide examples of queries in your tools, which can help like accuracy of your analysis can be improved by giving this kind of information to our MCP tools. So coming back to the presentation, in a way MCP servers are nothing but small minions running here and there doing the job. You can combine, mix and match. You can basically tell one MCP server to get some data, another one to get other data, and leverage that to reduce the time to debug certain things. You can understand things quickly. And of course, then you have the way you were doing debugging earlier, where the data was accessible for humans, is always there. But if the data is also available for agents or AI tools, you can also leverage the advancements that are happening in the LLM world to supercharge your debugging experience. So I have an open source MCP server that we have written at Last9. Last9 is an observability platform. And you can look at this as a reference implementation. Some of the examples that I shared with respect to how to write better tools, how to give more context to the tools are here. I'll also publish the local server that I had created for the RubyConf India demo also on GitHub. And that's it. Thank you. We are also hiring, so if anybody wants to talk about it, come and talk with me later.